Okay, so now we're going to focus on mean and median a little bit, and try to indicate what are some ways to do this with large groups of data. Okay, so here's one for you. AIDS data indicating the number of months a patient with AIDS lives after taking a new antibody drug are as follows, and they are in order from smallest to largest. Calculate the mean and the median. The first thing I want to introduce you to is this expression for the mean. This is called X bar. It's X with a little line over the top, and that means the mean, okay? So what happens is you have to add up all of those scores. That's a lot of scores, okay? And that's where if it was organized in a stem and leaf plot, it might be really helpful for you, okay? Add them all up and divide by the number of scores, which is 40, and you get 23.6. So you're not doing anything different with finding the mean, okay? However, with finding the median, if you were like, I used to teach this to kids. Sometimes I teach a middle school class, and I'd say, okay, if you want to find the median, find the one in the middle. And I'd say, cross off 3 here in the beginning, cross off 3 in the end, cross off 3 more in the end, cross off the next 3 in the beginning, and keep doing that until you whittle away to the term or terms left in the middle. But there's another way to do it, and you've heard me referencing it already today twice without actually defining it. To find the median, you first use a formula, and I don't want to get too nuts about a formula. Look, there's 40 scores here. If there's 40 scores, then the median, because there's an even number of scores, 40 divided by 2 is 20. Because there's an even number of scores, there'll be 2 scores in the middle. So you get your answer, which is 20, and then you also get the one above it, which is 21. So anytime it's an even number of scores, you get 2 in the middle. So you're looking for the 20 to 21st score and the average of those. So if I come into here, all right, and I go to the 20th and 21st scores, I'm going to go to the point where I come across 2 24s. And so I can circle those 2 24s. I know that that's the median because the average of 24 and 24 better be 24. Or if you want to be real formal about it, you can do 24 plus 24 is 48, divided by 2 is 24. Either way, the median works out to be 24. So what do you get out of this slide? You get out of the fact that you still do the mean the same way, even when there's lots and lots and lots of scores. But the median, you can take a shortcut. Rather than crossing them off and trying to find the one in the middle, you just take the total number of scores, cut it in half. If it's an even number of scores, that means you're going to get 2 sets evenly. So if you have 40, you cut it in half, you get 20. You're going to get 20 in the beginning, 20 in the end. And because it's an even number, there'll be 2 scores in the middle, okay? If it was an odd number, let's say it was 41, and I did 41 divided by 20, well, it would go in evenly 20 times, but there'd be a little leftover. And anytime you get that 0.5 leftover or a half leftover, that means you'd have a group of 20, and 1 in the middle. So if you do the division and you come out to 20.5, then you know it would be the 21st term, okay? All right. So let's look here. Suppose in a town of 50 people, one person earns $5 million per year, and the other 49 earn $30,000 per year. Which is the better measure of the center? Which one better represents the group of population? Is it the mean or is it the median? Have you think about that for a minute. Sure you're doing stop and start. Okay, now look, if you've got 50 people and absolutely everybody earns $30,000, which is not much these days in a year, and one person earns $5 million, can you see that the $5 million is like an outlier that's going to make it look like everybody makes a lot more than they really do, and that the better measure is the median, which is the 30,000 put to the 30,000? See, look, if I figure out the mean, which is X bar, we talked about that before, that's the new symbol for mean. If I add them all up, I have 49 30,000s, multiply them, add 5 million and divide by 50. It looks like the average, the mean income is almost $130,000. The median is $30,000. Which one is a better representation of what this community is like? Clearly 30,000. 49 of the people earn 30,000. Only one person earns 5 million. So the median is a better measure of what the center of the mean looks like. Okay? Not only is the median 30,000, but so would the mode be 30,000. Your first and third quartiles would be 30,000. It's definitely a better sense of the middle of the data. Okay, next. In a sample of 60 households, one house is worth $2,500,000. 29 houses are worth $280,000, and all of the others, which is 30 houses, are worth $315,000. Which is the better measure of the center, the mean or the median? Well, this is the same thing. Okay, the median is going to be a better measure. Anytime you have an outlier, the mean is not trustworthy. Okay, think about if you were a student and you were taking tests in a class. All right, and let's say that your test scores were 99, 99, 99, 99, 10. And on the day you got 10, you had the flu. Now, that's really going to mess your average up. It's going to change your average from a 99 to, like an 80. Is an 80 an accurate representation of who you are, or is the 99? Truth is, the 99 is a better representation. So whenever you have an outlier, whether it be a number that's too much, like 2,500,000, or a number that's too low, like a 10, when all the other test scores were 99, it skews, which is what we're going to talk about in the next session. It skews the data. It messes them up. So what we have here is that the median, whenever there's an outlier, the median is, normally speaking, a better judge of the center. Okay. Statistics exams for 20 students are shown. Find the mode. Now remember, mode is most frequent or most popular. It is possible to have more than one mode. You're looking for the score that you see the most. And that is 72. There are more 72s than anything else there. All right. The last thing we want to talk about with this mean stuff is we want to talk about, well, how do you figure out the mean if you have some grouped data? And the truth of the matter is, it's absolutely impossible to figure out the mean of grouped data. So we're going to not determine exactly what the mean is, but we are going to estimate what the mean is, okay? How do I estimate what the mean is? Well, I'm going to like for instance, if we look at this table, one student is in the interval from 50 to 56.5. There's nobody from 56.5 to 62.5. Notice, of course, all these intervals are the same width. That's very important. There are 4 students who are between 62.5 and 68.5, 4 between 68.5, 74.5, and so on, all the way down to 1 student between 92.5 and 98.5. So the way we estimate this is the very first thing we're going to do is figure out, hey, what's the midpoint of the intervals? And how do you find the middle or the midpoint of these intervals? Well, whenever you want to find the midpoint, you add them up and divide by 2. For example, if you had test scores of 90 and 100, you add them up and divide by 2. Your average, your midpoint, is a 95. Likewise, if you had an interval that went from 90 to 100, your midpoint of that interval would be 95. Now, this is a little awkward because the intervals are 6 units each, and that's not the norm. But it is what it is. So the first thing I have to do is find the midpoint of all of those intervals. So I add them up and divide by 2. And I do it for every single one of those. Now, what do you think you would have to do next toward calculating the mean? Well, you have to understand that this midpoint is what we're going to assign as being representative of the interval. And there's only 1 student in this first interval that gets a 53.25. There's nobody with a 59.5. There's 4 people with a 65.5. So this interval has a lot more people in it. So if I was writing out these scores in a list, it would go 53.25, 65.5, 65.5, 65.5, 65.5, 71.5, 71.5, 71.5, 71.5, 77.5, 77.5. You can tell that there's certain scores that are repeating themselves because their frequencies are greater than 1. So what I'm going to do for calculation purposes is multiply the frequency, the number of students, times the midpoint score, and that tells me how much value each interval would have. So here I have 1 times 53.25, then no value there at all. 4 times 65.5, 4 times 71.5, 2, because the frequency is 2 times 77.5, 3 times 83.5, 4, 89.5, and 1, 95.5. So what you notice is that when I go to multiply, it's just the product of the number of students. Notice they all match. 1, 0, 4, 4, 2, 3, 4, 1, and the midpoint, which gives us an average, if you will, a representative value over each of those intervals. So once I have this, that tells me how many scores, points, totals, if you will, are in each interval. So then if I add up all the intervals, and I don't want to divide here by 2, 4, 6, 8, there's not just 8 scores here. I want to divide by 19 because that's the total number of students, right? There's 1 plus 0 is 1, and 4 is 5, and 4 is 9, and 2 is 11, and 3 is 14, and 4 more is 18, and 1 more is 19. So I want to do this sum, which is 1460.25, divided by 19, rounding off, I get 76.9. And that's how I figure out the mean from group data. What's your big summary point here? The summary is that finding the mean of group data, you want to find the average or the midpoint of every interval, multiply it by how many scores or students or whatever you want to call the last column here are in that interval, then add up those totals and divide by the total number of, in this case, students or the frequencies total. Okay? That's how we do it. All right. So that's a review of mean, median, and applying it to groups of data.